Okay, just gonna erase this so we can do the next one. Okay, so our next one. What we'll do here is the reciprocal function, so that's 1 over x. So 1 over x. So we have the reciprocal function here. All right, so what is our domain? So this one's unique. So if you enlarge it, this reciprocal function, you could place dotted lines here and we'll get to what those are. Okay, so our x values, if you look here, if you read it this way, it has all our x values that are negative and all our x values that are positive. So it's all the values of x negative and x positive except for one point. It never touches where x is 0. It never touches where x is 0. So this is how we do it for the reciprocal function. So we say XER, and instead of listing it's everything less than 0 and everything larger than 0, which you can do, we just say x does not equal 0. Okay? So what that means is x is every single value, so all the negative values, all the positive values, except 0. Okay, so all we have to do is list the one it's not, rather than saying it's everything less than 0 and everything greater than 0. Okay, and likewise for the y values, our range. So again, you might see f at x ER. Okay, but I'm just going to use y for now. So YER. So again, we have all, if you look at the graph, it goes down, down, down. So it goes all the way negative. So it's all our negative y's. And if you were to go this way, it's all our positive y's. So it's all our negative y's and all our positive y's except where y is 0. It does not touch the origin. So it's all our values of y except it's not 0. Okay, so our range is all values except for 0. So we just say it's not 0. Okay, so now intervals of increase and intervals of decrease. Okay, and again, you have to read it left to right when you're doing intervals. So let's read here. So if I read or look at my graph going left to right, what is happening to the first part of the graph? Well, it goes here and then goes downwards. So here is a decrease. So this is a decreasing graph if we read it left to right. Okay, so we're going to have an interval of decrease. Okay, but this has two parts to the graph. It has the first part, which is in the third quadrant, and then we have the first part, which is in the second part, which is in the first quadrant. So again, if I read this left to right, it is going downwards. So this is also decreasing. Okay, so for this part here, intervals of increase, we do not have any, so none. Okay, or you put NA, not applicable, because there isn't any intervals of increase in this graph. So now we're going to do the intervals of decrease. But you notice we have 2. So we're going to have 2 intervals. We're going to have one for the first part, one for the second part. So we're going to have lowest value, highest value, lowest value, and highest value. Okay, so if I were to read it this way, what is my lowest possible, since it goes this way? So it's continuous to the left and it's continuous downwards. We're looking at our x values, remember, so our x values. So it goes all the way to negative infinity x. So negative infinity around the bracket. And then this, it keeps getting closer and closer to what x value? We're not looking, this is going y. So what's the x value here? Well, it keeps getting closer and closer to this asymptote here. This asymptote here is x equals 0. So it keeps getting closer and closer to where x is 0. So we put the highest value, so lowest value is negative infinity, the highest value is 0. But it never touches 0, so it's around bracket. Should do this in a different color. hopefully this is not getting, so from negative infinity to 0. Okay, but so that's the first part of the graph. So now the second part of the graph is up here. So what's our x values? What's our lowest value? And what's our highest value? Well, our lowest value, again, it starts very, very close to this axis, which is x equals 0. So it starts at 0, but it doesn't ever touch 0. So we have an open bracket there, or round, open bracket or round bracket. Okay, and then it keeps going more and more positive, our x's. So it goes to positive infinity. Anytime you have the infinity sign, you put a round bracket or open bracket. Okay, next part, location of discontinuations, or any does it stop anywhere, and then are there any asymptotes? Okay, so let's first put where it discontinues. And where it discontinues, we're looking at the domain. Okay, we're looking at our x values. So if we look here, it breaks here. So at this point here, it breaks. So that discontinuation happens at x equals 0. So the first part is the discontinuation, and now we're going to do the asymptotes. Okay, so here we also have 2 asymptotes. Okay, so there's 2 lines where the graph will never touch. Okay, so the first point is where it will never touch where x is 0, and it will never touch where y is 0. Okay, so it's discontinuous at x equals 0, and the asymptotes is when x is 0 and when y is 0. So in the back of the book, you'll see that x equals 0, it happens twice, or appears twice. That's because one is the discontinuation, and then one is the asymptote. Just double checking this to make sure that is correct. Okay, are there any x-intercepts? None. There aren't any x-intercepts because it never crosses the x-axis, so none. Any y-intercepts? No, it doesn't cross the y-axis at all, so none. Don't put NA, put none. Don't put 0, because 0 means it actually crosses at the origin, so don't put 0, it's none. Okay? Symmetry, odd or even. Again, let's reflect it. If I reflect it over the y, it will look like this. If I reflect it over the x, it'd be the same. So then it would also be an odd function. It has not an odd function, but an odd symmetry. And lastly is our end behaviors, which again I'll write over here are end behaviors. Okay, so as x approaches and y approaches. Okay, so as x here gets more and more negative, okay, this is the interesting part, so x keeps going more and more negative here, so it approaches negative infinity, so x goes negative infinity. What is happening to our y value? Well, this keeps, as we keep going here, this line keeps getting closer and closer to 0. Okay, so it keeps getting closer and closer to the the x-axis, which is y equals 0, but it never touches it. So it approaches 0. So as x gets smaller and smaller, more negative, the y values get closer and closer to 0. So as x approaches negative infinity, y approaches 0. Okay, now looking at the positive part, so if x goes this way, so x keeps getting larger and larger, so x approaches positive infinity. This line keeps getting closer and closer, keeps getting closer and closer to the x-axis, where y is 0. So this also approaches 0. So as x gets more and more negative, or approaches negative infinity, y approaches 0. On the same side over here, when x approaches positive infinity, or keeps getting more and more positive, y approaches 0. Okay, I hope this helps. There is one very trick one, which is the sinusoidal wave with regards to listing these out. I know a couple of these parts are going to be very tricky, especially the intervals of increase and decrease. So I know I will have to take those up. Please join on the homework questions and the 4th block of the day, and I can help you guys with that. Other than that, it should be good. Just a reminder, page 23, numbers 4 to 7. So please complete this chart and please go through the questions 4 to 7. Okay, have a good day.